So welcome. So we're going to look at the fundamental trend in the periodic table, the atomic radius. So first, you need to understand what effective nuclear charge is. So nuclear charge is, as you'd expect, dependent upon the atomic number. And so as there are more protons added to the nuclear charge increases. But the valence electrons don't experience the full effect of that nuclear charge because there are inner core electrons. And those inner core electrons do two things. Because they are negatively charged, they're going to repel those valence electrons, which are also negatively charged. And then they're also going to shield the shield those valence electrons from the nucleus. So essentially reducing the effect that the nuclear, of the nuclear pull, let's say. And so the effective nuclear charge is the resulting charge that's experienced by those valence electrons. So factoring in both the nuclear charge and the the inner or core electrons. So if you wanted to quantify it, here's an example. So take a moment to find sodium and chlorine in the periodic table. You should notice that they are in the same period. Sodium's in group 1 and chlorine's in group 17. So they have the same number of shells. So they both have 3 occupied shells of electrons. So they have the same number of inner or core electrons. So they both have 10 inner or core electrons, 2 in the first shell, 8 in the second shell. So we're using these Bohr models because they're sufficient to understand the trends. So if you take a look at what that core charge is and subtract from that if you take a look at what the nuclear charge is and subtract from that the number of valence electrons, you'll end up with the core charge, which is essentially the effect of nuclear charge. It's just a way to quantify it. So for sodium, that would be 11 minus 10, which is a charge of +1. And for chlorine, that would result in a charge of +7. So that essentially is the charge or the effective charge that the valence electrons feel. So the strength of the pull that they feel, factoring in. So even though chlorine has more electrons and it's actually going to feel a stronger pull because the nuclear charge is greater. In terms of atomic radius, and you'll see in a second how that relates. The atomic radius, the technical definition is half the distance between neighboring nuclei. So there's 3 ways to measure it. You can measure it by metallic radius, the distance essentially between like 2 metal atoms. You can measure it covalent radius in terms of if you're looking at a covalent bond, like a diatomic molecule. Or for noble gases, you'd have to actually use the van der Waals radius. You don't need to worry about that right now. But there's 3 different ways to measure it. But to simplify it, it's essentially the distance between the nucleus to the outermost electrons in that Bohr atom. What is the atomic radius trend? This image illustrates the trend. So as you go down a group in the periodic table, the atomic radius increases. And as you go to the right, it decreases. And so we'll look at why each of those trends exist. So when you go down a group in the periodic table, this should be pretty straightforward. You're increasing or adding more shells. So because you're adding more shells, you're adding more inner core electrons. So you're increasing the repulsion between the nucleus and those valence electrons. Okay, so there's essentially what I said a little bit more succinctly. The trickier one is going across a period, because you would typically think that, you're adding more electrons, so the radius should be larger. But if you think back to the effective nuclear charge, what's actually happening is that effective nuclear charge is also increasing. The effect that those valence shells experience, that effective pull increases, so it pulls in those outermost electrons closer to the nucleus. So it actually decreases because the effective nuclear charge is greater. And that is a better description than what I just said. So how does the atomic radius relate to other periodic trends? Essentially, you use atomic radius and effective nuclear charge to explain most of the other trends. So when you are explaining your trends, you will want to refer back to the atomic radius as part of your explanation as to why those the values increase or decrease. So always think back to atomic radius and effective nuclear charge, and that will help you explain why those trends change. Okay, so test your knowledge. I've given you 4 pairs of atoms and see in each pair which one is the larger atom. So which one has the greater atomic radius? And these are the answers. And let me know if you have any questions about any of those pairs.